So this physics question asks us what the minimum speed that a cart on a roller coaster can move at so that it doesn't lose contact with the track. So it tells us that a roller coaster is moving in a vertical loop or a vertical circle. So it's going to come up like this and move around and then come back down like this. So the motion is in a circle. And despite the fact that it's in a non-uniform circular motion, and we know that because its speed is decreasing on the way up and it's increasing on the way back down. But despite that, the movement is still in a circle and therefore still has radial acceleration or a centripetal force. So according to Newton's second law, we'll have the normal force plus the mass times the gravity, and that's because it's plus because those two forces are moving in the same direction at the top. So we'll have that set equal to the mass times the radial acceleration. Well, the radial acceleration is equal to the velocity squared over r, and we still have this mass here, and so our second portion of this equation is going to become this. So we have the normal force plus mass times gravity is equal to the mass times velocity squared divided by r, or the centripetal force. So in order to separate the normal force, which is what we need to know for this portion, we would subtract mass times gravity from both sides, get normal force by itself, and we'll have this equation. Now, since we notice that the mass is in two different portions of this equation on the same side, we can factor out the mass once this is set equal to 0. And we can divide both sides by the mass, basically eliminating the mass. We no longer need to know what that value is. And so we're just left with this is set equal to 0. So we know the normal force is 0. So in order to get the velocity at the top, we now have to separate the velocity by itself. So we would add gravity to both sides, we would multiply both sides by r and have it cancel over here. So we'll have velocity squared at the top of the roller coaster is equal to the gravity times the radius of the roller coaster. So in order to get the velocity by itself, we would square both sides, and so the square root and the square would cancel, giving us the square root of the gravity times the radius is equal to the velocity at the top of the roller coaster. And whenever we plug in those numbers, we'll get 15.7 meters per second is the minimum velocity that the roller coaster can move without losing contact with the track at the top.